To have another example on integrals involving powers of sine and cosine. We're asked to evaluate for the integral of sine to the fifth x cosine cube of x dx. So for the solution, we have the following. That is, we let this sine to the fifth x cosine cube x dx to be equal to, we can rewrite your cosine cube x dx as cosine squared x times cosine of x. That's 2, then plus 1, which is equal to 3. And then, since cosine squared x can be rewritten as the integral of 1 minus sine squared x, so that we now have the integral of sine to the fifth x times the quantity 1 minus sine squared x times cosine of x dx. And if we let u to be equal to sine x, then we can compute for du, which is cosine of x dx. So that this one becomes u to the fifth 1 minus u squared times our cosine of x dx is our du. To say we have the following, that is the integral of u to the fifth times 1 minus u squared du. And if you recall, we actually have the following. The integral of u to the n du is equal to u to the n plus 1 all over n plus 1 plus c for all rational number n not equal to negative 1. So meaning to say, if we try to take the integral of u to the fifth times 1 minus, we can distribute u to the fifth times u squared there. So u to the 7th du. We'll have u to the 5 plus 1 all over 5 plus 1. Meaning to say, we have u to the 6 all over 6. Then the integral of u to the fifth times the negative u squared will now become u to the 6, u to the 7. So we have 7 plus 1, that becomes 8, all over 7 plus 1, so all over 8. So we have the following, that is 1 over 6 u to the 6 minus 1 over 8 u to the 8 plus c. But we have to go back to the original value of u, which is sine x. So we now have the following, 1 over 6 sine to the 6x minus 1 over 8 sine to the 8x plus